Hello everyone, this is Mrs. Lindsay, and today we're going to talk about the derivative and slope of a graph. Okay, so what is a derivative? The derivative is the slope at a specific point on a graph. Okay, so in other words, we should be able to draw a tangent line, and I just put a few points on here. We'll start with the circle. The tangent line anywhere along these points on our circle. And we should be able to find the slope or the instantaneous slope at that particular point in time. So again, I should be able to draw a tangent line of any of these points. And I'm just randomly picking some and drawing tangent lines that hit at exactly one point. Okay, so some of them are going to be horizontal lines. Again, I'm randomly just picking some and drawing some tangent lines, and we should be able to find, again, the instantaneous slope. So the slope at this point, for example, will be different than the slope at this point. This slope here would be a horizontal line, so it'd have a slope of 0. And this one, we don't know exactly what it is, but it's increasing, so it should be a positive slope. Okay. So again, it changes from each point. So this slope here would be a negative slope. And it would be different than this slope over here, which is going to be positive, which again would be different than this slope. It's going to be, this one probably is increasing at a greater rate than this one. So again, we should be able to find the derivative or the instantaneous slope at any specific point along the graph at any point in time. Okay? And we're going to explore this a little bit more in class and talk about the difference between what it means to find the derivative and slope over a rate of time. So let's estimate the slope at x equals -2, -1, 0, 1, and 2 of this parabola. Okay, slope varies on the curve that are not lines. So again, we kind of talked about that before, so let me just go ahead and put x there, and then I'll write slope here. So let's think about these points here. So if I look over here at -2, for example, okay, so there's actually my x-axis. If I look over here at -2, we could probably say our slope is somewhere around -4. Again, it's going to be a negative slope, fairly steep. And then if you go over here to -1, you could probably say it's going to be about -2. 0, hopefully you'll understand that that would be a horizontal line, so that would also be 0. At 1, this would be a positive slope, right about there, so I would say that's probably about 2. And then again here, my slope is increasing rather lengthy there, so that's probably about 4. And again, we're approximating these, but again, what happens with all these, at each of these points, slope is different. Again, it varies. If I would have chose -3, if I would have chosen -0.5, its slope is going to vary again if they're not lines. Okay. Alright, so hopefully you've already watched, if you haven't, what is a derivative from the calculus tutorials. If you haven't done that, please go ahead and take a minute and watch that. It's a fairly short video, but again, it describes what is a derivative. And again, we're going to explore this a little bit more in class. But if you haven't done that, please pause and watch that. Okay, so after watching that, you should know where this comes from, and this is what we call the difference quotient here. This is our difference quotient here, and that is the definition of a derivative. Definition of derivative. So the limit as h approaches 0 of f of x plus h minus f of x all over h is where we find slope at a point. Again, we'll explore this a little bit more in detail in class as well. So that's the formal definition of a derivative. These are all the same as well. What is derivative? It's the instantaneous rate of change. It's slope of f of x at a single point. It is the slope of the tangent line to f of x at a point. And then again, here we have the derivative definition, the limit as h approaches 0 of f of x plus h minus f of x over h. So again, this is the difference quotient. Alright, so some notation, I have one written up here as well. So we use the f prime of x, and that's actually how you would read that. So f prime of x. You'll also see notation with y prime. You'll also see notation dy over dx. All of this means derivative. And again, typically we read this. You'll see this notation, we'll use that. These two probably most of the time, but this is also the exact same thing. We'll read that as f prime of x. Sorry, my window got mixed up there a little bit. Okay, there we go. Alright, so let's go ahead and jump into an example here. Okay, so given f of x equals 2x squared minus 3x, find the derivative of f. So I have up in the corner there, I have the difference quotient written down, and that's how we're going to find the derivative. So again, this is what we're finding over here. So let's go ahead and jump in and find the derivative. So I have the limit as h approaches 0. Now I'm going to find x plus h. That is going to be plugged into wherever I see an x into my original function. So I have 2 times x squared minus 3x. So again, notice I put parentheses there representing what am I going to plug in for x. Well, what plugs in for x? The quantity, x plus h. And then I subtract my original function. Well, that's my original function. But extremely important here that we put parentheses around that function. And it's all over h. Okay, so from here on out, we're going to do a lot of simplifying using our algebra skills, formulating, combining like terms, etc. Okay, so I'm first going to take x plus h times x plus h, and I would get that to be x squared plus 2xh plus h squared. Distribute through the negative 3. And here's why I put the parentheses around this and why it's so important. We have to distribute through that negative sign. We're subtracting that entire quantity, so it changes the sign. What we typically forget is on that next term. And that's all over h. And then one more step, and we can see some things at that point in time after we distribute through are going to start canceling. So we'll have 2x squared plus 4xh plus 2h squared. And then all of our other material all over h. And now let's see what starts canceling. Okay, so like terms, 2x squareds cancel out, 3x's cancel out. So then we get limit as h approaches 0 of 4xh plus 2h squared minus 3h all over h. And we can still simplify. If you notice here, we can actually factor out a common term of h. So if you want to take that extra step, factor that out. If you can factor it out, it can cancel. Otherwise, don't forget, some people want to skip this step. That's absolutely fine, as long as you remember h is over every one of these terms. So if I cancel out an h here, I have to also cancel out one h here and one h here. So again, if you can cancel it or factor it out, then you can cancel it. Okay, so I'm going to continue over here. So that means the limit as h approaches 0 of 4x plus 2h minus 3. And then our last step would be to substitute in 0 in for h. So our limit, or our derivative, I should say, of our function is 4x minus 3. Now what is this exactly? Okay, so remember when we talked about at the beginning of the video, what is a derivative? Derivative is the slope at a single point anywhere on a line. Well, this is the formula to find slope at any point on that graph. So on our original graph here, f of x equals 2x squared minus 3x. If I use this formula, if I want to find the slope at x equals 3, I plug it into there. If I want to find the slope at x equals 20, I plug it into this, and that will give me the slope at those points. Alright, so let's go ahead and try another example here. So I would like you to pause the video. I want you to try to set up the very first step on this. So we're going to do this in a few steps. So I'm going to have you set it up, and then I want you to push play and check your answer. And then we're going to have you simplify it, and then I want you to pause it, check your answer when you get done with that. So we're going to kind of do this in pieces. So go ahead and do that first step where you substitute that in and find the difference quotient. Okay, so here it is, the first step, plugging in. So again, you're putting x plus h in for your function here, and then you're subtracting the original quantity, and notice I have parentheses around those. Okay, I'd like you to go ahead and pause the video again, and then simplify. Distribute, add like terms, and then push play to check your simplification before you actually find the limit, and then the derivative. Okay. So I distributed, and then I canceled out. As I combined like terms, x squared canceled out, the 2's canceled out, so I was left with 2xh plus h squared over h, and again I took out an h out of each of those. So I have the limit as h approaches 0 of 2x plus h. Now to find that final step of the derivative, I have to substitute in 0 for h. So my derivative is 2x. Okay, so let's go one step further with this. Again, what is this 2x representing? Well, we want to know what would the equation of the tangent line 2f be at negative 2, f of negative 2. Well, if you recall, we have point-slope form here. So we need to find slope first and foremost. The derivative tells us the slope at any point along that graph. If we want to find it at x equals negative 2, slope at x equals negative 2, we use our derivative, and we substitute in negative 2. So, this should be negative, sorry. The slope at negative 2 would be negative 4. So again, the derivative equation gives us the slope at any point along the equation. Now we just need to find our x1 and our y1. Well, we know our x1 is negative 2, so I can plug that in. That would be plus 2 there. Well, how do I find my y? Well, I need to find f of negative 2. So again, I'm not using the derivative here. I'm going to go up to the original function, which is x squared plus 2x, and substitute it into there. So I'd have negative 2 squared plus 2. So that'd be 4 plus 2, which is going to give me 6. And then I can substitute that in. Now it doesn't say if we have to put it in y equals mx plus b form, so we can just simply leave it in point slope form. That is the equation of the tangent line when x is negative 2. Or specifically at the ordered pair negative 2, 6. Okay. All right, so last but not least, what's the purpose of finding the derivative? It describes the slope of the curve at any x value. It also represents the slope of the tangent line. Then we can write the equation of that line using the point of tangency. And there's got to be a shorter way to do this, and absolutely there is. This is using the fundamental definition of derivative, and we will get there. Again, I know we have shortcuts, but again, we first need to understand what is a derivative and what's the definition of it. So we will get there sooner than later. Okay? All right, this concludes the day 1 of derivatives.